the tutorial for Chapter 4, Section 4, Graphing Linear Equations in Slope-Intercept Form, Day 2. So let's take a look at the first problem. It says graph each line, state the y-intercept, x-intercept, and the slope is what we're going to end up doing. So let's take a look at our first problem, and it says y equals 2/3 x plus 6. Well, 6 spaces up on my graph, I'm not going to be able to make it, so I'm actually going to modify this equation just a bit. We're going to end up going up only, let's go at 1, 2, 3, 4. How about 4 spaces, because that's what I can fit on my graph. So I'm going to go ahead and change that real quick and change this to a 4. So I'm going to go up 4 spaces, 1, 2, 3, 4. I'm going to put the dot right there. That is the y-intercept. So whenever it is in this form where it says y equals mx plus b, so y is by itself. We've got the x term with a coefficient in front and then a constant on the outside. And that's what I see here. The 4 represents the y-intercept. And the slope of my line is this value right here. This is my slope. This is what changes the input each time. So my y-intercept is 4. So I'm starting 4 spaces up, and then I'm following the slope. Now typically that slope tells me to go up 2 and then right 3. That's what the positive 2 tells me to do and the positive 3. But I can't go up 2 and right 3, so I'm going to end up having to go a different direction. So a positive slope is also a negative over a negative, since 2 negatives make a positive. And then that would tell me to go down 2 and then left 3 spaces. So down 2, left 1, 2, 3, and that gets me on that line. And that's all I have room for, so I'm going to draw the line between those points. Now on this next one, I'm going to end up modifying this one a little bit too, because I can't quite fit this number on the graph I've got. So I'm going to change this. And actually, we'll go ahead and leave it the way it is. We'll go ahead and modify the way we end up our intervals. And so this is one way we could end up doing that problem. So I end up adding 10 to both sides. I want to get the y by itself. And so when I do that, I end up getting y equals negative 5x plus 10. Now I decided to leave it in there because sometimes when the numbers are so big, we do have to modify our intervals. So right now my intervals are typically 1, but let's change it. Let's go by, let's see, I can go by 1, 2, 3, 4. I've got to be able to get 4 spaces up, so I'm going to go by 5s. I'm going to go by 5s this time. So this is going to be like 5 right here, and this is going to be 10, and I've got 15 and 20. And so if I'm going to go by, I'll go by the same intervals here. And instead of that, I think I'll stick with 1s. So I'm going to go with 1, 2, and 3, and 4 going on the x-axis. So you just have to notify the reader what you're doing if you end up changing your intervals. And so if I do this, I'm going to start with the y-intercept. The y-intercept is going to end up being 10 in this case, because it's the number that is added to the x term. That is the y-intercept, or we also call it the b term. And then my slope is equal to negative 5. And I can treat that as a fraction, as negative 5 over 1. So this number right here represents my slope. And then we'll go ahead and use those points to graph the line. So I'm going up 10 spaces on my graph, and then I'm using the slope. The slope is 5 to 1. So I'm going down 5 spaces, and then I end up going 1 to the right. And that gets me on that line. So looking at my slope, I go down 5, 1 to the right, down 5, 1 to the right, and that gets me on that line. So I can go ahead and draw a line between those points, and that represents the line y equals negative 5x plus 10. Now I've talked about the slope and the y-intercept, and those are given to me on my graph, but I also want to find the x-intercept. The x-intercept is where the line crosses the x-axis. So where the line crosses the x-axis. And so I see that the y-intercept is where it crosses the y-axis. I see that here, but I don't see it on this line. Now I'd have to carry the line out a little bit further to figure it out, and I could probably do that. See, if I go down 2, right 3, so 1, 2, 3 would end up being that third spot. So this is like 1 spot over. So That was 1, 2, and then this is the third spot over. So if this point is -4, this would be -5, and this would be -6. So my x-intercept for this problem, x-intercept, is going to end up equaling -6. Now let's come up with another way to find that. And so notice that the x-intercept has a y value of 0 and an x value of -6. So just as the y-intercept had a x value of 0 and a y value of 4. So you're not going over any places in the x direction to get up to that y-intercept. So let's use that concept here to help us figure out what this value of x would be. So if I look back at the equation, y equals 2/3 x plus 4, if I go ahead and substitute in 0 in for y, I don't know what the x-intercept is quite yet. I did find it in this case, but let's say I didn't know what it was. I do know that the x-intercept has a y value of 0. So if I do that, I have 0 equals 2/3 times by x, which I'm not sure what it is yet, plus 4. So I can go ahead and solve by subtracting 4 from all sides, and I end up with -4 equals 2/3 x. So now if I multiply by the reciprocal, I will cancel out that fraction. Do the same thing over here, times by 3/2. See, the 2 goes into -4, -2 times. If I multiply across, then -2 times 3 makes -6. And that's another way of finding those intercepts, is to set the other variable equal to 0. So again, I see what the y-intercept is, and on this problem, it is going to end up being 0, 10, because I just go up 10 spaces. And I see that this one has a x-intercept of +2. But let's go ahead and use that same concept here to try to find that x-intercept a little bit differently, noting that the y value is 0 for the x-intercept. So let's go ahead and use this concept here on this problem. Let's use the original equation, y minus 10 equals -5x. Let's set y equal to 0, and then I just have -10 equals -5x. See, if I divide by -5, I end up with 2. 2 is x, and that's the same value I got for the x-intercept when I looked at the graph. So we're going to use that concept on this next problem. Let's take a look at it, and it says the equation y equals -90x plus 1,440 represents the time in minutes left after x games of a tournament. So it tells me what x is right here. X games of a tournament. So let's put in number of games. Number of games of a tournament. And then along the y-axis, we're going to end up having, let's see here, it says the equation represents time in minutes. Okay, so time in minutes. Alright, so from there, let's go ahead and come up with some units. Now, I could definitely just go by ones along the side here, but I think I'm going to change it a little bit. I'm going to go by twos just to make it go a little bit further. So this is like 2, 4, 6, 8, 10, 12, 14, 16, 18 in this last spot would be 20. Now going up though, notice how high I have to go. I have to go all the way to 1,440. So I've only got 10 spaces. So if I was to go all the way up to 1,440, I'd have to divide by 10 to find out how many spaces in between I could have. Well, that'd be 144 spaces. So if I did 144 each time, I would get up to my top spot would be 1,440. But 144 are kind of difficult spaces to come up with. So what I decided to do is just go up by something a little bit less, a little bit more, because I want to make sure I end up having enough space. I'm going to go, well, 144 is about 150. And 150, it's easier to go up by. So I'm going to show every other point here. So this would be 150, 300, and then I continue on. So 450, this would be 600. And so it's kind of like going by 300s here. So I just skip every other space, and my next number is going to end up being 900 up here. And then this is going to end up being 1200. And my last one is going to be 1500. And you see that's pretty close to where my 1440 is going to go. So I go ahead and plot that point. So 1440 is the y-intercept. Remember, it's y equals -90x plus 1440. And so this is my y-intercept here. Y-intercept. That's where it crosses the y-axis. So I'm going to start at that point. So 1440 is somewhere around here. So this one, it's going to be just a little bit lower than that 1500, right around there. And then I'm going to find another point. I could go down 90 over 1 each time, but that may be kind of tough. I'm going to use that concept of the x-intercept, which says this. If I go ahead and substitute 0 in for y, let's find out what x is going to be. And so now I've got this equation to solve. And so I'm going to go ahead and move that 90x over. So I'm going to add 90x to both sides. And so now I've got this, 90x equals 1440. And so when I divide by 90, well, I see that those zeros cancel out because 10 goes into each, but 9 goes into this number as well. X is 16. And so that means I have another point here at 16. And then I could just draw a line in between those points. And that would represent my line. And so I don't have any negative time, so I'm going to just lop that time off because it's going to definitely end right there at the x-axis. And so there it is. So let's see what this represents. So now we've got a little bit more representation here. So we've got, first of all, the initial value here. So the initial time or with no games, we'll say, after 0 games. So there's no games that have been played yet, and this is the total time, so initial time after 0 games, or the total time. And then time begins to decrease as games go on. And the 16 represents the maximum number of games in the time provided. So I can't go any lower than this 16 because that would mean that I'd have negative time. And I can't go any further up because that would mean that I have negative games. So I have to start with the initial time after 0 games, the total time that we had to do this, 1,440 minutes. And then I was able to play, out of that 1,440 minutes, 16 games. So that was the maximum number of games. And then the slope, which we'll just draw a line like that, represents 90. It means that the slope here represents that I end up going down 90 per 1. So that means that I lose 90 minutes, or we have 90 minutes per game is what that represents. So each game we would have 90 minutes for. So that's what the y-intercept represents, the slope, and that x-intercept. Those are the types of problems you'll see on tonight's homework. Good luck.